Okay, before we started, you get any question, anything else to me, just let me know.
Thank you.
I just have a question on the homework. Mr. Ty sent out an email if we need help on it, just to call calling the line. Who's answering the line, and what should we anticipate? Because I've started to do a lot of the homeworks, and 2 or 3 of them I've gotten stuck on. So what should we anticipate when we call, or when should we call? I guess probably a better question.
Okay, if you get a question on the homework, okay, then the one can be helping you, myself, Sam, or Mr. Ty. And you can text to me, okay? Or Sam or Mr. Ty will be helping you. And I try to get as much at the lecture done, then I will be spend time with your guy on homework, any homework, okay? Okay, anything else? Okay, if it's not, going back to the lecture last time, we're talking about the differential amplifier. Okay, I just quickly go over very fast to that differential amplifier. Every time you see this circuitry here, that's what we call a differential amplifier. Differential amplifier, that means they get an input number 1 and input number 2, and output 1 and also output 2. And this is a symbol. Okay, this is a circuitry inside the symbol here. So you get input 1, input 2, output 1, output 2. That's the only thing. What you need to recognize that. And also in this one, they just detail on telling you, okay, basically DC calculation. However, only thing we need a Q1 and a Q2 must be identical. RC1, RC2, same thing, okay, in order to build the amplifier. On that one, they just telling you, okay, if you get the input 1 round, input 2 round, the same input, then the output will be look like the same, okay? And now on this circuitry, okay, they apply the input to the input 1. Output input 2, they round it. So if you're looking into the output, you can see this is the output 1, and this will be output 2. Also, you need to know a little more. When you apply the input number 1, then the Q1 will be working at CE amplifier, okay? And the CE amplifier, input positive, output negative. Input negative, output positive. Input, output 180 degree of phase. So when you apply the sideways here, also at meter of Q1, you get the same sideways. And that side wave will be go into the emitter of the Q2. So Q2 will be working like common base, okay, amplifier. So input positive, output positive, input negative, output negative. Everything will be explained to you in that one. Okay, and now they're doing opposite. Input one route, input two, you apply the sine wave. Okay, then the Q2 now will be common emitter, and the Q1 now will be common base. Okay, and that will be showing you a little more detail with the signal. They apply input one sine wave and input two routed. So Q1 CE amplified output will be opposite to the input. Okay. And Q2 will be a common base. Okay. And common base input output will be in phase. Same thing on that one. If you get a question, just stop me, okay? Let me know.
I just have a practical question. I guess it's going back to the inputs, outputs is where, this is an amplifier for, I guess, should we think about a stereo? Like a car stereo or home radio? The inputs go in from a radio into an amplifier and outputs being to speakers?
Now that depends, okay? If you're looking at schematic of the circuit of the amplifier, okay? And you will be recognized. Now, what happened? You can see they can using that one. But what is the purpose of this differential amplifier? That they only telling you if the both input get the same signal, then the output will be 0. That means this amplifier try to ignore the noise from the input. So you understand your voice, microvolt, that's a very, very small signal. And also in the input of the amplifier, they can get the noise signal. The noise means unwanted signal. The signal you don't want it, but they be there. Normally that will be affected by the radiation from the outlet, the power. So if they get about 1 volt sideways, okay, at the input of the differential amplifier, the noise they affect is not only input one. They have to be the same thing on the input two. Okay, and your voice is too small, they will be buried inside that voice, that noise. So they cannot, you cannot see it. In order to do it, the differential amplifier try to cancel out the noise. And they just using the gain of the amplifier multiplied by your voice. That's why they can go into the output. So that is the main purpose of the differential amplifier. try to cancel out any noise coming into the input of the amplifier. And now if you're looking on the next one input one you apply sideways, okay? And the input two they routed. So you get the two output, one negative, the other one will be positive, opposite. And that will be the same. So now you get the two input sideways apply to one input two. The one you have to pay attention. Those two input they must be opposite. That means this one going up, this one must be going down. If they same thing, then the differential amplifier considered to be the noise. Okay, so they cancel that. So make sure if you want to apply the input to the differential amplifier, then they must be opposite 180 degrees out of phase. And the output one you get negative, output two you get positive, just inverted. And this will be trying to explain to you a little more on the common mode. That means due to the noise, this one here or this one here. You see both input positive, negative, the same, identical. They consider to be the noise. This amplifier try to cancel that. And they say common mode input, both input are the same phase, same frequency, same amplitude. Applied to the two input, output are superimposed and they are cancelled, resulting in a zero output voltage. Okay, this action, that's what they call a common mode rejection. They try to cancel the noise. Common mode rejection means that this unwanted noise signal will not appear on the output, the desired signal. Common mode signal, that is noise, generally are the result of the pickup of radiated energy from the input line, from agent line. Okay, and the common mode rejection ratio we call a CMRR. We calculate by the formula to take the AVD. What that means? That means the gain of the differential amplifier divide to the ACM. ACM means the gain of the common mode. That means the noise. Also, they already given anything here. Okay, AVD differential voltage gain, ACM common mode gain. The higher the CMRR, that is the better. The common mode rejection is often expressed in the decibel dB, following the formula 20 times log of AVD divide ACM. And this example, they already given to you. Last time we already calculated for you, okay? And also did the same problem, different value. And we already did two calculation for this example. So normally you have to do your calculation on a common mode rejection. So any question confusing to this example? Okay, if it's not, now the differential amplifier, I give you example. Differential amplifier show single-ended output. What that mean? That means normally you get two output, now they want only one output. That's what they call a single-ended output. So they given you a VD. That means the gain of the differential amplifier 2500 and CMRR equal 30,000. They given you V1 500 microvolt IMF. That means your signal right here. And this is the noise, identical signal, VCM, okay? At the same time, a 1 volt 60 hertz common mode interference signal appear on both inputs. First thing they want to determine the common mode of the gain, ACM. So I already get a solution for you. You get a common mode rejection ratio equal AVD over ACM, then ACM equal AVD divide common mode rejection. You get 0.083. Okay. And second, express CMRR in dB. You take CMRR 20 log of 30,000. You get 39.5 dB. And they want to know the IMS output. V in differential equal V in 1 minus V in 2. V in 1, you get a 500 microvolt. V in 2 will be 0. No. So that's why you get 500 microvolt. V out equal AVD, the gain of the differential, time V in differential. 2500 times 500 microvolt IMF, you get 1.25 volt IMF. Any question on this example? Okay, if it's not, go next one. Next example. For the differential amplified circuit show, they given to you AVD 2500, CMR 30,000, V in 1 equal V in 2, 500 microvolt IMF. Okay, that means the same time, same thing like the previous example, except now they apply two input here. Okay, if you're looking into the two input here, they will be opposite. This going up, this must be going down. Okay, and they want to know the IMS output. So the solution, V in differential equal V in 1 minus V in 2. You get a 500 microvolt minus 2 minus 500 microvolt. You get a 1 millivolt IMF. Then V out equal AVD times V in different. You take 2500 times 1 millivolt, you get 2.5 volt IMF. And they want to know, determine the IMF interference voltage on the output of, output, the IMS output. So ACM equal V out divided to V in. So V out equal, no, ACM, that means the gain of the common mode equal V out common mode divide V in common mode. So V out common mode equal ACM times V in common mode. Okay, and V out we already know that will be 0.083. That ACM times 1 volt. That means 1 volt for the input. You add 83 millivolt. So basically, the noise also they get the gain for the noise. That's what they call ACM. Okay. So VL normally calculation will be take the gain of ACM times the input of the ACM. Same thing for differential. If you want to calculate the V out of the differential input, you take the VAV, that means the gain of the differential input times the V in of a differential input. Okay, so any question on this example?
Mr. Pham, I got a question on part A. What's the solution? No, don't move it.
Yeah.
Solution part A is the fact that when you have V out minus V in, so 500 microvolts minus minus 500 microvolts. So that comes from the V in one of them's positive and the other one's negative. So is that where the minus came from?
Okay, V in right here.
Part, yeah, the solution A, yeah. Mhm.
Yeah. That's why you get a V in minus V in 1 minus V in 2.
So the minus 500 that's in parentheses, that's the negative part of the VN on that schematic.
Exactly. This input 1, this input 2, they must be opposite.
Okay. And that's why you got your negative sign.
Right.
All right, okay, thank you.
Okay. So that will be N for this differential amplifier. And now I will be going into a next one. Let's see. Operation amplifier. Okay. Next one, we're talking about the operation amplifier, op-amp. So when you're looking into that simple here, that's what they call op-amp, operation amplifier. They get two input, input 1 connect to the negative, input 2 connect to the positive input of the op-amp. And this is single-ended output. You get only one output. Try to see what's going on for this amplifier. Okay, they set 3 terminal device. Inverting input to minus side. That is minus side of the op-amp. Non-inverting input, okay, plus side. This is the plus side here. 2 power output and 2 power supply. Okay, and basically op-amp they need 2 power supply. normally going from plus minus 8 volt to plus minus 38 volt. That means if you apply input 12 volt power supply, then the other one must be minus 12. If you want 15, then the other minus 15. Okay, what we're working in the lab, normally we're using 12 or 15 volt power supply. Okay, now ideal op amp. This op amp we never see, but we need to know. Open loop gain, AOL, they want to be infinity. Okay. What they mean for open loop gain?
It's too high.
No, that not mean too high.
Open loop gain means you don't have a bypass resistor in the circuit.
Now, open loop gain means the IC itself not connect anywhere.
Right. There's no bypass.
Yeah, no connect anything. You can go to buy op amp, 7041 op amp, that IC. That they get the gain ready when they build in the manufacture. And normally the gain, open loop gain around 200,000. You cannot do anything with that open loop gain. Okay, so basically they say open loop gain, you want it to be infinity. That means they're telling you as large as possible. And input impedance. So between the positive and the negative, you get a resistance. Okay, you get a resistance in between positive and negative. That's what they call input impedance. They want that to be infinity. Why they want it to be infinity? The reason is they don't want any current go inside the op amp. They get a big resistance. Okay, so output impedance, that means before they going out, they get a resistance. That's what they call output impedance, and they want to be zero. The reason they want to be zero, you want maximum current can coming out. Okay, and also the different input, that means the different input between positive and negative of the op amp, they want that to be zero. V in at positive minus V in at negative, you want that to be zero. That's basically definition for the ideal op amp. Okay, and that one you can see right here. When you're working on the lab, normally you give C. That op amp, they get only 8 pins. Okay, 1, 2, 3, 4, 5, 6, up to number 8. Pin number 7 will be a power supply positive, and pin number 4 will be negative power supply. Okay. So, any question on this slide? No. Go to next one.
I have question, Mr. Fan.
Yeah.
Like, what do you mean by zero between negative and positive?
V in plus minus V in minus equals 0, right? V input at positive minus V input,
Negative?
yes, equals 0.
Oh, okay, I see.
That means the difference between two input, and that's what they call a VD.
Oh, okay, yeah, makes sense now. Thank you.
Okay. VD, what that means? Differential between positive and negative of the op-amp. And they want that to be 0.
The same frequency and the same amplitude, right?
That doesn't matter. Okay. Normally you apply to input. And no matter what, the difference between that, they want it to be 0. Okay, now, let's see. I can give a little more detail here. If you get the AOL equal the gain, normally the gain of the amplifier will be the ratio between V out divided to V in. However, in this case, they have to be in VD. That means the difference between positive and negative. Okay. So from this formula, I want to know VD. VD equals V out divide AOL. Okay. V out AOL. What do you want AOL to be?
Infinity. So is equal 0.
Infinity. That's what we're just talking here. Open loop gain AOL equal infinity. Okay. So any number divide infinity, you understand they be equal 0. Okay, so only thing you make sure you must be understand, but keep in mind the different source input VD all the time. They want that to be 0. Okay, just that one will be giving you a little more information. So this is the IC 741 op-amp. And what pin to do what, okay? And this is the practical op-amp representation. Practical op-amp, high gain, voltage gain, very high input impedance, very low output impedance, and they get a wide bandwidth. You know the bandwidth, right? That means the difference between two frequencies. Okay. Wider, more signal can be transmitted. Okay, now we go to practical op-amp. that the op-amp will be working on. Output voltage Vout equal V in at positive minus V in at negative time AOL. Okay, that means differential input time the open loop gain. VD difference between two inputs. The gain AOL open loop gain of 741 close to around 200,000. That means when they build IC 741 op-amp from manufacturer, they already get the gain, and that close to 200,000. The output of op-amp is never higher than the power supply voltage. Okay, that will be telling you if you're using the power supply plus 15 volt and minus 15 volt, then no matter what, output of the op-amp cannot be higher than 15 or minus 15 volt, no matter what. Even to see the gain is 200,000. That not mean the difference apply between input 1, input 2, 1 volt, you time at 200,000, you get the 200,000 volt. That never happened. That's what they say. No matter what, output of the op-amp cannot be higher than the power supply. So basically, you're using power supply plus minus 15 volt. Then the output of the op-amp will be less than 15 volt or higher than minus 15 volt. At it. When the output of op-amp is never than power supply, when the input supply is too high, that force the op-amp into saturation. Okay, when the op-amp go into saturation, what happened? Who knows? If I said the op-amp already saturated, then what happened? Mr. Smith, you know it?
It won't work.
When they set up the op-amp is in the saturation, then what happened?
The signal being disturbed?
It's well, the term saturated means you have too much of something.
No, they already saturated. Then what happened to that op-amp? I say the op-amp is saturated. What happened to that op-amp?
Man, you don't get no more signal.
No,
It's not going to work.
that's not right. Okay, I'm telling you. When they said the op-amp is saturated, then you want to calculate the output, you cannot using the gain anymore. They saturated, that means no more gain. That's the first thing. The second thing, the output, either they go to 15 volt power supply,
Yeah, the power supply.
or they go to the negative 15 volt. Either one.
It's
If they saturate.
go to the max power supply. Yeah.
So that's why I said try to understand it.
So, Mr. Pham, So
Yeah.
you're saying that, I wish you say it again, but it sounds like you're saying it got maxed out because of the power supply.
Can that be interpreted as full scale?
This is the max, yeah.
It's at max plus, in other words. Whatever maximum is, it's saturated, it's beyond its maximum capacity.
This is the power supply. If they saturated maximum output, either equal positive power supply or negative power supply. They can be 15 volt if you're using power supply 15 volt, or they can be negative 15 volt.
But if it's saturated, it's more than, say, if it's positive, it's more than 15, or if it's negative, it's more than negative 15. Because saturation means you're it's like an overflow.
That's only telling you they be saturated if you try to apply too big input,
Right.
and that's forcing the op-amp to saturation. That's only telling you, if you say the gain here 200,000, you cannot using the gain anymore if they be saturated. Okay, make sure you understand. If I said the op-amp is already saturated, then you can telling me output either they can be equal positive saturation or negative saturation. You cannot using the formula to get the gain time to the input to get the output. They don't have any more gain. And they will be explained to you when the output will at the positive power supply, or they will be at the negative power supply. Okay. Now, normally, what they telling you in here, when input applied too high, that forces the op-amp into saturation, and op-amp output will be equal plus or minus saturation voltage. That saturation voltage normally less than a power supply 1.4 volt. That means just telling you output they will be less than 15 volt. Okay, cannot be higher. If they not given voltage saturation, they consider power supply voltage that like saturation for simple calculation. Open loop gain AOL is defined as the amplifier output amplification without any external feedback signal connect to it, and for a typical operational amplifier is about 100 decibel at a DC 0 hertz. So basically the handout I gave it to you just try to summarize what really you want to memorize. You don't have to read any textbook. Only thing is, when you go to the handout, you can understand what we cover for you. That'd be good enough. Okay, for this slide, okay, any question?
Yes, Mr. Pham. It says the typical operational amplifier is about 100 decibel at DC. Does that mean it's max for saturated, or does that mean that the percentage of op amps used
That's
will,
just a,
will only work up to 100 decibels? Or is that the minimum range?
yeah,
Is that
that is the range for the DC. You understand DC mean no frequency. Okay, and that cannot be happen. That's just a for open loop gate. Op amp itself, not any connection. Okay, now, if you can do on this thing, that will be telling me you understand. What they said, op amp had open loop gain 200,000 with a power supply 15 plus and minus 15 volt. And they also given you saturation voltage of the op amp plus or minus 15 volt. They ignore the small number difference. They want you to complete the VD, that's the VD, and V out in the following. Number one, they given you input positive 20 microvolt, input negative 40 microvolt. You calculate for to me what VD equal and what V out equal. Go ahead and do it, telling me what you get. Try to active into the Zoom. That means you must be doing. If you not quite understand, just go ahead and ask it. Don't waste your time, okay?
Hey, Mr. Pham, did you get 12 for the V out for number one?
What VD equal?
Wait a minute, I have to go back. VD is 20 microvolts plus 40 microvolts, so that's 60 microvolts. And then it's 60 microvolts times 200,000.
Okay, VD equal Vs positive minus Vs negative.
Isn't that negative 20?
Minus 20, right?
Minus 20.
20 minus 40 is negative 20, right?
Yes.
I suppose that.
20 minus
40.
40.
You
But-
get minus 20.
I thought the formula was minus, wait a minute, hold on. That's a plus, minus the input, negative input. Yeah, minus 40, I got that wrong. So that's 40,
Ah,
2 volt out. Be output.
E6 negative. My thing. 0 E6 negative.
for some reason,
Uh,
I touched something, I get the same problem last time. I try to figure out how can I fix that. Okay, that'd be fine.
Okay, so the first one, I stand correct. Should the V out be 4?
Okay, now I need to
Yeah, 4 volt.
add number. Just a minute.
Yes.
Did anybody get 4?
Yeah, 4 volt.
Right.
Okay, I need to explain to you in here. The first thing is you know what is the gain. AOL 200. Is it right?
200,000, right,
That they given.
right.
Okay,
That's open loop
Oh.
gain.
open loop gain. Okay. So V out VD time AOL. Correct?
Correct.
Okay. So now we have to find out op-amp is saturation or not. Okay. So we want to calculate the VD. They equal V out divide AOL. And V out, if saturated, they can be 15 or minus 15. Okay, so first thing I said, if they get 15 volt, divide 200,000. What they equal? If they saturated,
7.5 micron.
15 divide 200,000, what you get? Is it 75 microvolt? Is it your calculation? Coming up 7. Is it correct or not?
Yep.
Okay. And also you need to calculate the VD if they saturate at a negative power supply. Same thing, V out, AOL. However, now will be 50, 200,000. And now you get minus 75 microvolt. Okay, so I'm showing you this thing here. This is stand for VD. That is 0 volt. Okay, this is the limit 75 microvolt. And this side minus 75 microvolt. Okay, now, if VD higher than 75 microvolt, that means this area here, they already be saturated. And output, no matter what, they will be equal plus 15 volt. The thing is that the limit for input limit, okay? The thing is when you say they equal 15 volt, that means they already saturated. If they already saturated, what VD supposed to be? Do calculation, you get 75 microvolt. Okay, that means if the VD higher than 75 microvolt, then they be already saturated. And Vout will be equal 15 volt. And the second calculation also, you assume they be saturated already with the negative 15 volt. And you do calculation, you get minus 75 microvolt. That's a limit for negative saturation. So any voltage, okay, less than 75 microvolt, they be saturated. And they Vout will be equal minus 15 volt.
Hey, Mr. Pham,
Yeah,
so are we supposed to be operating between the negative 75 and the positive 75?
exactly.
Okay, so that's the area of operation.
This area here, they will be amplified with the gain equal to 100,000. If you want Vout, you take AOL time VD. That is summarized on the operation.
Question, Mr. Fan?
Yeah, go ahead.
What decides the range inside of the op amp in order to stay within that specific area?
Now the range of the input differential depend on what power supply you apply to the op amp. You
But-
want 15, okay, minus 15. You want 12 volt, minus 12 volt.
But the microvolts, the 75 microvolts, that range,
Doesn't matter.
but that depends on the chemistry of the op amp, right?
Right.
It's not a specific component.
Right. That will be telling you how op amp working when you get open loop gate. So on that one here, you get 20 minus 40, and my answer will be minus 20 microvolt, right?
Well,
And did you get VD minus 20 microvolt?
Yes.
Okay. Now, minus 20, that means they in this area here. So you want the V out. Then you take V out equal 200,000 times minus 20 microvolt. So what you get?
you get 4.
Okay,
You get 4.
minus 4.
-4.
Yeah, -4.
Okay, so the answer will be negative 4 volt. Okay, make sure you understand of on the first number 1, I do calculation. Now you have to do for me number 2 to number 8.
Hey, Mr. Pham, but just as a hint, for number 2, that would be 10 minus a minus 60.
Exactly.
Okay.
So try to do to see how many students get the right answer. This is a very, very basic. You must understand.
So 10 minus a minus 60, a minus is a plus, so it's 60 plus 10, which is 70. And then 70 times 200,000.
Okay, for me, I can get one, I get 70.
Yeah, that's 70.
And what the V out?
Volt.
14.
Exactly. Very good. Blood 40.
Correct, plus 14. And the next one will be minus 50 minus a minus 30. The minus the plus. So
Minus 20.
minus 20, right.
Very good.
Yes.
Kumi's a superstar. Good job.
Is that right for number 3?
Yeah, same as number 1.
Okay. I think you know how to do it. Homework is not a big deal.
The V out would be -4 volt.
Negative, yeah.
or negative.
Yeah, because the VD was,
Yeah, I copied wrong.
that's negative, yeah. There we go. $20 minus a minus is a plus. So that's 140.
140.
140. Yeah.
50 volt now.
All right, they saturated.
Yep.
I'm just asking, should that be 28,
Which one?
number 4?
We out.
Be out, shouldn't that be 28?
Come on.
Well,
It's
let me, see.
saturated.
How do you get 15, Mr. Pham?
Yeah.
That's
I
the
already
saturation
told you.
point.
What VD you get?
oh,
140.
that's right, it was saturated. Because you're only using 15 in
Right.
my.
Saturated.
Yeah, that's right.
Oh.
Yeah, I get what you're saying now.
Okay,
Yeah.
okay.
I was just doing the calculation, but yeah, it's saturated,
More than 75.
Exactly.
right,
The thing they higher than 75 microvolt.
right.
So they will be positive saturation. That's why you get 50.
Right.
Oh.
Minus 145.
Let's see. Minus 100, minus 45, minus 145.
And minus 50 volt.
Mhm.
Now,
Minus 145.
Mine at 145.
That's what VD is, but V out is minus 15 because if on the other side of that little table that Mr. Pham built, it's negative on that side.
We're talking about number 5, right?
That number 5, I already get the answer.
Oh,
The negative saturation.
Hey, Mr. Pham, maybe if you show her that table on the bottom again, she'll see what you're talking about. Yeah, right there.
can you say this one again, please?
Okay. VD you calculate equal minus 145.
Uh-huh.
Minus 145, that means they go into negative saturation. Right
Yeah.
here.
Yeah.
It's going to the left, Kumi.
Okay.
When they go negative saturation, VL equal minus 50.
Okay. Okay. Thank you.
You're welcome. Now, 3 more.
Hey, thanks for drawing that table, Mr. Pham. That makes it clear.
Yep.
I understand, so that's why I have to do it. Otherwise, you guys get lost.
That's for sure.
And later on, you don't know why 15 plus or minus 50.
Yep. Thank you, Mr. Pham.
Thank you. 110 minus 55.
Minus
65. 65.
65 plus minus plus equal minus.
Oh, yeah, because then you gotta go 65 EE 6 negative times 2 13.
When it's not saturation is more understand than
Yeah.
yes.
If they not saturate, you want to get the out, you take the gain time with the VD.
Right, right.
Okay.
So it's 65 microvolts times 200,000.
Minus.
The tricky one is 4 and 5, because you just got to look at the thing and see it. Okay, so minus 25 minus 75 is a minus 100.
Minus plus equal minus.
Okay, yeah.
Mr. Fan,
Minus 15 on that one? I'm sorry, go ahead. Whoever's getting ready to talk, go ahead.
no, I have a question. Mm,
Go ahead.
What happened when I get in BD 75, exact 75? Is saturated or we have output?
Saturate.
Okay,
That means they equal or higher or less than.
less than, okay.
Hey, Mr. Pham,
Thank
for this one on number 7, since we have a minus 75 and a plus 75, and the minus 100 is different from the minus 75, so then the V out would be minus 15? Yeah. Right. Plus 130, 90. Plus 1, 2, 3, 4.
Yeah, more.
If you get to it, you understand how we get that value, you okay.
On number 8, the VD should be negative 40 microvolt and V out should be negative 8 volt.
Number 8, let's see, you get a minus 130, minus 90. Yeah, thank you, Sam.
Yeah, it's true. Thank you.
Yeah. That
Number 8 is, so that's yeah, minus 40 and then minus 8 volts. Yeah. All right, Sam, we're going to give you your certificate.
He a younger man.
Yeah. You can say
I'm too old.
that.
So that's why you get the homework problem at Sam. I think he's working very hard.
Relax.
We ask him every day.
Okay, so next meeting will be continued, okay? On that part here. And we get only 2 more weeks. Then we get a holiday, Thanksgiving, for 1 week. So next week, I will be talking about left fold with the semiconductor circuit board. And we'll be working on the full wave rectifier. I pick up some different circuitry in X1, okay, to help you. Some very simple that I don't get. And now I already know how to control my camera. Next time, you guys will see much better. Okay, so any question, anything? Okay, if it's not, now Sam, you ready?
Yes, sir.
Okay, I stop share on my.
Okay, thank you. Okay, so make sure you download the e-quiz number 5 from the website. So from the website here. And so if you at the home page, click on the handout, click on this one right here, the first one. It's a e-quiz 05 fall 2021 report. That's the one that you're going to put all your answer on and that you're going to upload it to the website when you're done with the test, okay? Or the quiz. All right, here we go. Okay, can you see that?
Yeah.
Okay.
Ooh.
Hello. Hello, how are you doing? Alhamdulillah. So, أنا كويس. مليحة قعدت على الرأي.
Mute the mic, mute the mic, mute the mic.
علاقة زاوية.
Okay, so that's pretty much it. So make sure you upload it onto the website. Let me go ahead and stop that. So does anybody have any other question? Make sure you upload it to the website when you're done. Like I said, you can go in here and just click on upload file and just come in here, type in your name and last name and just click on upload. Okay. So make sure this is due before 12 o'clock tomorrow. All right. So anybody ever need extra help on homework, you can contact me, or like Mr. Pham said, you can contact him and he definitely can help you. Let me see, my contact number is here. Let me maximize it. Okay. So this is my contact, and I'm pretty much here on pretty much Monday to Friday. So if you prefer different time that you need extra help, so text me at my text me, and then we can schedule a different time for the to meet. Okay, we can work with you on Zoom, and this is my Zoom contact number and my password, or you can email me. Okay. So anybody have any other question or need any extra help, go ahead and post it here while we still have a little bit extra time. Okay, no question?
No. Thank
Okay.
you.
Thank
Thank
you.
you.
Thank you. Back to you, Mr. Pham.
Thank you.
Thank you.
Thank you, Sam.
So,
Okay, good night, everyone.
Good
good
night.
night,
Good
Mr. Pham.
Thank you.